What is negative mass?
Oh my goodness, I don't know. I guess it's a theoretical mass because if we have positive mass, and what's the opposite of that? Negative mass.
I
I don't
guess
know if we've ever seen negative mass.
if we scroll up a little bit here, there's a link we can click on. Right there, yeah.
Let's
What
do
does it
it.
say?
In theoretical physics, negative mass is a hypothetical type of exotic matter whose mass is opposite sign of the mass of normal matter. For example,
Okay, yeah.
negative kilograms.
Okay, good. Okay.
That's pretty much what I said. Yeah, right.
Yep.
Yeah. Such matter would violate one or more energy conditions and exhibit strange properties such as the oppositely oriented acceleration for an applied orientation. Oh my gosh, so you push a block and it comes towards you? Weird.
Oh, have you seen that experiment? Have you seen that experiment with negative mass? It's so cool. It is so cool.
Uh-huh. I think you're lying.
Actually real. It's a real thing. It's a real thing. It's not actually
Shut
mass.
shut the front door.
It's,
No, that's not.
No, yeah. All right, we gotta watch that because it is really cool. It's not.
Really?
It's not actually negative mass.
Mm-hmm.
But it uses clever liquids to do it.
Okay. Like one of these, like when you're braking in a car, where do the balloons go? That thing.
What?
So if you're driving in a car, you got your car full of balloons, and then when you brake, where do the balloons go? Do the balloons go forward or backwards? The balloons go backwards because the more massive the air, which is the fluid in your car, goes forward, which displaces the balloons to go backwards.
This is exactly
backwards things.
Yeah, this is exactly what the principle at play when this guy did the video. It's such a cool video though. It messes with your mind, man.
I'm so salty. I'm so salty because in high school, we went to my friend's house and her stepdad was an engineer. And so for like 2 hours, he's like, "Oh, you guys are going to go to college? You guys are going to go study science and engineering? Let me grill you on some questions that I happen to know." Like, I came here to eat dinner with your friends, like the kids.
Yeah, adults were weird. Can we watch that video? Because that's kind of a cool video.
Oh, okay. What are my search terms?
YouTube negative mass. Probably be the first one. That's so false. It is. Yeah, this guy.
If you pull a ball on a string, it lags behind because it has inertia. But if that same ball had a negative mass instead of a positive mass, when you pulled on the string, it wouldn't lag, but it would move in front of you like this. So normally negative mass is considered a physical impossibility.
Correct.
But the weird thing is, in all the equations of physics, they work just fine if you plug in a negative mass instead of a positive mass.
Okay. Well, we don't have to get... I just want the
You wanted to see the motion thing?
Yeah. Because it's cool because he moves it to the right, but then the ball you think would lag behind, but actually goes forward. The water's rushing backwards.
Is it true what he said that if you plug in negative mass, all the equations still work? I think it's not disallowed, but also it doesn't make sense, right?
I think this is one of those things where it's like in electromagnetism, it's like we can put a magnetic field into. We can make all the equations symmetric by putting magnetic field with magnetic monopoles in the equations. I can do it, but it's not physically realizable as far as we know. So yeah, we can make the equations pretty if we want, but
it's something like if we put in the negative mass here, all the dynamics are still okay as long as we absorb another negative into the force, like that type of thing.
Oh no, I think it's like, gosh. So in Maxwell's equations, there's the divergence of the magnetic field equals 0. And we could say that the divergence of the magnetic field equals enclosed monopoles.
And we just don't happen to see them.
We just don't have to see them. But it's not violating anything.
Because to me, this is a vectored equation, right?
Yep.
So to me, these are actually different equations when you put the minus sign in.
I see. There's some statement about absorbing. Depends what you mean by the absorbing of the.
Right. We define acceleration as the negative direction of whatever.
So somehow you would still write it as F equals ma, because m is free to be any number
Mm-hmm.
that we measure. And if we
Right.
happen to measure one of the masses as negative, then that number would be negative. It's still F equals ma. So I guess the left side would be F equals ma. M can be any positive number,
Mm-hmm.
and the right side would be F equals ma. M can be any real number.
Oh, you mean any negative number? You said real.
I did.
But
I
real.
just said real. So the left side is positive only mass. The right side is any
Positive and negative?
Positive and negative allowed.
Oh,
So you
I
don't
see.
have
Okay,
that
okay.
restriction.
We're thinking about this. Okay, I see what you're saying.
You're okay, but now you're saying on the right side, let's restrict it to negative mass.
Yeah. But that's the
Um,
same thing as saying only positive.
Wait, say that again.
If we restrict the right equation,
Yeah.
we say this is only going to be negative mass.
Yeah.
But then we have negative mass times the negative. This is actually the same. This is actually the same equation. If you put the limit of negative mass only for the right equation.
Yeah. Yeah. So I guess what you want to do is, okay, in that case, left side is F equals ma, mass restricted to be positive.
Mm-hmm.
Right side is F equals ma, m that the letter m is restricted to be a positive number.
Right. So that way you get the actual negative stuff. Like,
But I think the
Which-
Newton's laws with negative mass allowed is F equals ma with m allowed to be a real number, any real number.
okay.
And then, so I can, like, mass could be 5 kilograms or negative 2 kilograms or 0.
Mhm.
Could be anything.
Right. But then you have to absorb. Oh, I see. No. That still can't be right. Because if I put in a negative number,
Yeah.
I recover the original equation. If I put in a
Well,
positive mass, I now have F equals minus acceleration, right? It's like the wrong way.
Right. So if we're allowing negative mass,
Oh, no.
Wait.
It's okay. I caught up with you. The acceleration and the force will be in the same direction. It's just this quantity is a negative mass thing.
and so when we have a negative mass, if we have a negative mass, force this way, acceleration's this way.
Mhm.
If we have a positive mass, acceleration's this way, force is this way.
Oh,
I think the definition of negative mass is force is opposite acceleration.
I see.
Which
I was thinking this would be the equation for things that have negative masses, such that this number in here is a negative number, such that when you multiply by a negative, you end up getting the force and the acceleration in the same direction, and then all the dynamics work out the same. Like otherwise the dynamics don't make sense, right? You apply something and then it goes the wrong way.
So I see what you're saying. You're saying interpret the right equation as F equals minus ma. All mass is restricted to be negative, and when you plug in a negative mass, you recover F equals ma.
Mm-hmm. Such that if I'm like ball in the air, release, and then it should behave the way it should, right? Like,
I see. I'm thinking, let's look at the behavior, and if the force is opposite the acceleration, that's negative mass. But we never see it, but it's
I
allowed.
see. I see what you're saying. Okay.
Yeah.
So if there's like mirror world where things are backwards, then like this equation applies.
Right. Similar to like, that's why I brought up the Maxwell's equations, where it's like we can put in monopoles.
Mm-hmm.
It's allowed, but we just never see it. But we want it so bad.
Yeah, it would be so pretty for the equations.
Right. We want it. Gosh, there's other
Okay.
ones too. Gosh.
Sure.
String theory. Oh boy. No, thank you.
I mean, I think we have this in quantum mechanics where you have a negative. You effectively distribute the negative into here, and now
Yeah.
you're in a tunneling regime.
Yeah, so there's subtleties in there because sometimes just adding a negative to
Mm-hmm.
the equation, like it's absorbed into the equation somehow, and everything turns out fine. Then I think there's other equations where it's like I cannot introduce a negative because it becomes unphysical.
Mm. I mean, back in the day, we thought that a minus sign in here is unphysical. You're trapped by the barrier. You can't go through the wall. But then, hey, like, you can tunnel through it.
Right.
And then in that scenario, it is kind of similar where you have this item that has a property that's being overwhelmed by other properties, like just like
Okay.
that the ping pong ball in the mineral oil. It has low mass compared to the mass of other stuff.
Mhm.
Whereas when you're tunneling, you have low energy relative to the barrier.
Right.
My opinion.
Yeah. Actually, can we watch this video one more time? This is a negative mass video.
If you pull a ball on a string, it lags behind because it has inertia.
Inertia.
But if that same ball had a negative mass instead of a positive mass, when you pulled on the string, it wouldn't lag, but it would move
That's-
in front of you like this. So normally negative mass is considered a physical impossibility, but the weird thing is, in all the equations of physics, they work just fine if you plug in a negative mass instead of a positive mass. So this has led some scientists to believe that negative mass actually exists in the universe.
Okay.
What do you think?
I just really like that picture of him pushing the jar one
Mhm.
way and the ball goes the other way. And so in some sense, it's not negative mass because if you work
It's
it
a
backwards,
negative relative to the fluid that it's stuck in.
right? So it's like a negative relative mass. So it looks really weird. And
It
I
does.
guess if you wanted to model it in some way, you could say F equals ma with m negative if you wanted to.
That's true.
And you could model it that way, you knowing that it's kind of a, fun simulation, a fun experiment. But
As long as it lives in the soup of whatever oil this is.
as long as it lives in the soup, yeah. So that means that whether mass is positive or negative in some sort of like tabletop experiment game is actually a statement about what fluid the object is immersed in, and it's not a statement about the actual inertia of the object.
So if we had a universe with like hypermass and then things with a little bit of mass, would be relatively negative mass.
Relatively negative mass. And I guess if space-time had this high mass density to it, actually, the cosmic microwave background is like the soup of the universe.
Yep.
So if you had a density less than that, if you pushed on it, it would go the opposite way.
It's a relative negative mass.
Oh my gosh, really? Whoa.
I mean, I guess so.
I think that's right. I mean,
Should
the
we-
mass
should
density
we-
would be low.
Should we not put this on YouTube?
Just totally put this on YouTube. There's no way somebody hasn't thought of that. There's no way.
I don't know. Stuff gets invented like that.
That's true.
Copyright. Don't steal this.
Yeah.
All right, see you next time.
See you next time.